Hello, everyone, and welcome to another workshop webinar. Today, we'll be discussing network scale circuit emulation as a way to modernize your TDM network and migrate from just a SONET infrastructure and a packet infrastructure to primarily a packet infrastructure using circuit emulation. So one of the questions that we hear a lot is, how can I retain my high value or required DS1s, DS3s for like voice services or data services for anything from a bank to, you know, any other company, or DS1s for a company, but not have to maintain a SONET infrastructure, right? Because that SONET infrastructure is becoming less and less cost effective. It's hard to find spares for it. It's hard to find people who know how to use it. It's hard to find maintenance contracts for it. So look, how customers ask, how do I get off of this SONET infrastructure? And that's the question we'll be answering today, right? So the proposal is to use network scale circuit emulation. You know, what is it and how do you use it? Now, circuit emulation has been around since 2002, 2003 over packet networks, taking DS1s, DS3s, and encapsulating them into a packet infrastructure. Just put them in a packet, send it over the network. Now, there's more to it than that, and there's a lot of standards that can do this. We use MEF standards, Metro Ethernet Forum standards for it. But the primary thing is understanding the basic technology and why you would apply it and what you would gain out of it. And that's what we'll review today, including some of the applications. So Tejas Networks is a 20-year-old company. We're celebrating our 20th anniversary this year. And we started out as a SONET and Ethernet company back in 2000. And, SONET over Ethernet over SONET and Ethernet alone. Now we've combined them all together in a single platform to move forward with. And I've got a couple of examples here with me, right, that I'll show you a little bit later on how that structure works. Our headquarters is in Bangalore, but we have a Dallas headquarters as well here, and labs around the country. In fact, a workshop that I'm in right now is an operating lab. So it's really good. It allows us to take a look at and test out all the applications we need to do here in the US. Now, we have a lot of technologies within Tejas, but one of the biggest ones is our software-defined hardware. And through the use of FPGAs, we're able to create technologies that run in hardware, so they're low latency and they're quick and they're stable, right? But flexible enough to adapt to working, today's environment where you have a lot of different protocols and a lot of different structures. So what is network modernization I'm going to talk about today? So 15 years ago, right, I really like analogy, so I'm going to, use the road analogy again today. 15 years ago, we built a SONET infrastructure. You all did. I was part of it, right? We all had fun with it. SONET was great. It was a nice road. It wasn't very big, but it was a great road. It was well paved, worked perfectly well, right? But times have changed, and now our networks kind of look like the middle picture, right? It's a packet infrastructure that's usually pretty high bandwidth, but it may be busy, may not be busy. But on the side, it has a running parallel SONET network. And you kind of got two highways sitting side by side, one that's really big and got lots of room on it, and one that's smaller and probably got a lot of room on it too. So, but they're running in parallel, and that's not so great because the utilization rates are down, and you kind of have to understand two technologies at once, kind of maintain two technologies, right? And it gets a little exasperated, a little difficult, right? So our objective is to have one network that's fairly busy, right, with packet and SONET on it, right? And the scaling problem is what has prevented us from being able to put a lot of DS1s and DS3 on the packet network until recently. With the larger FPGAs that I discussed earlier, you're able to get a lot of traffic through hardware and meet the SONET-like timing, bit error rates, reliability in a packet infrastructure. So what is network scale circuit emulation? In network scale circuit emulation, right, we take and move beyond just a service. So in service scale circuit emulation, at the top here, you had a CPE at one end and a CPE at the other end of a switch router network, right? So you circuit emulate it, you took in DS1s or DS3s, you put them into packets and you ran them over the switch router network, right? It was built for a few services. It often had timing slips, but you know, it wasn't a high priority service. It was usually built for enterprises. It often had problems with restoration times of greater than 50 milliseconds, but these usually weren't noticed very much, right? It had few protection capabilities, right? The devices at the edge were unprotected DS1s or unprotected DS3s usually, but this generally worked. But it was only at a service level. It was difficult to do 100 or, you know, more than 100 DS1s or large volumes. And the network itself wasn't capable of handling it, and the devices weren't capable of handling it. So network scale circuit emulation takes that and allows you to put many devices in the network to take your entire IOF, midspan meet, CPE, and run them over top of a packet infrastructure. But not only that, you can run it over, you know, dark fiber, DWDM, OTN, carrier Ethernet, IP MPLS. So you not only get a network level circuit emulation capability, but you get it over the top of more technologies. So you have more options to cost optimize your network, right? And this network scale circuit emulation replaces SONET ADM and DACS functionality. And when I say replace, I mean it really replaces it. It says I can do protected DS1s, I can do protected DS3s, OC3s, 12s, and 48s. I have redundant switch fabrics, proper timing, end-to-end timing, right? Integrated test sets like you would in a DACS, right? And you can do it in many different topologies: mesh, hub, spoke, all protected, and scale it to the level of 100 or 1,000 services, right? So, you know, I don't know whether you have 1,000 DS1s in your network, but if you have 100, it'll scale fine. Less than that, that's good too, but you get that reliability that you expect. So the general architecture is taking the existing SONET network on the left, right, and through network modernization, placing it onto a converged transport network, packet transport network, that will encapsulate, you know, all the SONET services, the Ethernet services, right, any broadband services, carrier Ethernet, et cetera. Place them all on one converged transport network. So the old network modernization, right, kind of orphaned, right, the SONET network. And that's how we ended up with two networks, right, or service-only network modernizations. And this is not the case with a full network modernization through circuit emulation, right? The result is you're able to remove the SONET technology, but keep all of that revenue, right? And it's not just keeping the revenue, but you keep the SLAs, you keep the entire package, right? It provisions, you can provision it like SONET, but it's over a packet network. You got the redundancy of SONET, just like you need. You got all the bits timing, you can deliver timing, everything remains the same. So why do customers explore network scale circuit emulation? There are a large number of reasons that we've come across for it. This is kind of a matrix of it. Just to run through it quickly here. The primary reason that people look at it for multiple applications on the left are that the equipment is aged. It's old. I mean, DACSs are pretty much MD'd. It's hard to find spare parts for them. There's a lot of cannibalization going on. A number of smaller SONET vendors have retreated from the market. A number of larger SONET vendors have retreated from the market. It's harder and harder to find parts and expertise. So that cost of that support is getting larger and larger all the time. And the value is getting smaller and smaller. right? So how do you cost optimize the increasing costs, right? And how do you, right, limit, get a good return on your investment going forward? Another way of doing that is that there's a lower cost packet transport in place. So packet transport at 10 gig is much cheaper than SONET OC192 to run, and your services, your TDM services might be less than that. So you can lower your cost of your packet transport. If you're leasing packet transport instead of leasing OC3s or OC12s from somebody else just to transport between two areas of your network, you can lower that cost as well. There's a significant difference between an OC48 and a 10 gig service, 10 gig e-service, I should say, right? A 10 gig e-service might run $3,000 to $5,000. An OC48 is around $10,000 for a lot of the cases that we've seen anyway. You can also reduce a significant amount of power, right? We've taken, bays of equipment and multiple bays of equipment and reduced it down to 1, 2 rack unit shelf. And that's not because of the extreme density, although this is a fairly dense shelf. It's that those devices have less and less traffic running over them, but they're still consuming almost all the same power, right? And they are consuming all the same space. And fundamentally, you can reduce the number of MOPs that you have in your network because you don't have to have a separate procedure base for SONET and then a separate procedure base for packet. You can merge those together, right? So we're looking at, over the years, moving to circuit emulation, but there's people have thrown up a number of challenges, and rightfully so, challenges to moving to a network scale circuit emulation, right? They've always, I've heard conversations around timing slips are always a problem. Well, yes, in a service-based solution that I described before, timing does become a significant issue because it's not very steady, right? It's not a steady clock, right? There's a lot of variability in it. But the network scale circuit emulation solutions were developed from SONET-based and packet-based merged together. So we can use bits timing clocks. We have adaptive clock recovery and dynamic clock recovery that are more stable. SYNC is becoming more popular in the network, and 1588v2. So packet-based and traditional TDM-based timing methods are available even at the same time. So we can use whatever we need to wherever in the network. Errors are more difficult to find when you use circuit emulation services. And that's the case for smaller ones, but these devices that we're looking at here, they generate loopbacks, they have integrated test sets for DS1 and DS3 services, and they have RFC 2544 to look at the packet transport and ensure it's working well, right? We have bulk service provisioning to handle the transition of services. Meet need points are still at OC3, 12, or 48. That's easily done. Our shelf over here has OC3, 12, and 48 ports on it protected that run ATS. That's not a problem anymore. The density is extremely good for the amount of services that you'll be used or transitioning at any point, right? And then the final two are over provisioning and guaranteed bandwidth. People are always concerned about over provisioning in a packet network structure and ensuring that they have guaranteed bandwidth. Well, there are techniques now with the MPLS TP and with the network management systems to be able to provision from end to end in a single step and make sure that every hop that you go through has the right amount of bandwidth available for it and consistently the right amount of bandwidth for it. So you don't get variability in bandwidth requirement or availability. It's a steady bandwidth pipe, just like SONET, and just what TDM needs for that service. So the Tejas Network Fast TDM network modernization can run over dark fiber, can run over OTN, carrier Ethernet, MPLS TP, or even over IP MPLS in a layer 2 VPN. So that in between two devices, you can have almost any network structure that's used in telecommunications today. That gives you flexibility to, at the cost point you want to go at, to reuse your existing infrastructure, to merge existing infrastructure and SONET infrastructure together. I should say existing packet infrastructure together, right? Or to run it over OTN from someone else, lease line it, develop it however you would like to. And we carried these services over thousands of kilometers to prove that the timing over different infrastructures will work. We've done it over carrier Ethernet, MPLS, right, over dark fiber, DWDM, right? And the tailored fit that you get out of it with the cost optimization is important. We can, you know, we're not looking at taking that $1 million you put in the SONET network infrastructure the first time and say it's $1 million to replace it. It's not. We're talking replacing a large network structure that was bought years ago at an expensive price, reducing it down to the proper level and being very cost effective with it. This is a very cost effective solution, right? And you can talk to our salespeople about that afterwards. Right? Right? So we have a single pane of glass to provision the system. So you can provision Ethernet and TDM at with the same wizards, the same provisioning methodologies, right? And when you're done with the TDM, these shelves, you can just remove the TDM blades and put in a packet blade and use it for traditional, you know, packet services, ELAN, E-line, E-tree, whatever service you need, right? So the solution itself is for a redundant configuration. We have two main shells, right? This 7-slot I'll describe first, right? It's selecting the commons, right? That's just the shelf with the power and the fan tray unit and the OANM on it. And the OANM that I'm pointing to with my hand here has the bits timing on it. It's a clock input, clock output, RFC 2540, you know, sorry. It has the 1588 V2 on it as well, right? Your selection of a packet switch card. Packet switch cards are here, right? And then pick out the line cards that you want, either OC3 1248 or DS3 and DS3, I should say. And then same with DS1. Now, protection is done with a 1+1 mode. So if you want protection, it's just buy 2 of them and go. So it's a very simple solution. It's not complicated. It replaces fundamentally what you were seeing with the SONET network. The only difference between this architecture and what you would see in a SONET shelf is the replacement of the TDM cross-connect with a packet switch card. Right? So Tejas also provides services for deployment. A number of them we call the white glove care package, and that's reviewing the network design, making sure that, you know, everything works properly together, so you don't have to, you know, learn a new technology, right? Or relatively simple, but new technology, and worry about whether or not you've got it right. We'll work all through that all with you. Field trials, right? We'll have a deployment consultant on the side, and we'll do training as well. And that's part of our white glove care package. And then we also have partners that can do engineering, installation, commissioning, and testing. And if you wish to do those yourself, we can be in the background, remote access to help you out with every one of those steps. So a number of case studies we can go through here. We had one in South Carolina that's deployed out here. On the left-hand side, it's hard to see because there's 11 Cisco 15454s, right? And that's in one central office, right? And it's, you know, 3 bays of equipment. And they need to collapse that down. Those were not fully utilized at this point in time, but not only that, they were consuming a lot of power. So we collapsed those 11 454s in 3 bays into a single 1407 2-rack unit shelf, right? And you're saying, well, you know, they could have consolidated that on the 454s, but that would have left them with the 454s and the operational problems anyway. So movement to a new packet infrastructure, the collapse is done once, and they're able to use the rest of the bandwidth that's available in a 64 gig switch to do packet services as well. So in total, they're looking to replace 40 nodes. They are going to use the 7-slot for a lot of those, and a fixed 1U called the P for other ones as well. And we help them out significantly by doing, you know, in the initial testing from the deployment. And it went so well, so quickly that they had an emergency DS3 that they had to put up, and they chose to run it over top top of the trial network, right? It went up, went in cleanly, and we had met the service obligations of the company. Another case study is there was a customer who had 6 old SONET nodes. They were, again, 454s running an OC12 ring, but a lot of it was meet me handoffs, right, at the OC12 level, right, and at the DS1 level. So there was 2 OC handoffs to other service providers that meet me at OC12s, and then there was their own DS1 traffic and a couple of handoffs to another customer at DS1s, another service provider. So we replaced those OC12 rings with 3, those 6 nodes with 3 7 slots in 2 10 gig rings. Not only did it give them all the TDM functionality that they were looking for, but it gave them another 38 gig of packet traffic. So they were able to modernize, find a cost-effective reason for doing that. It was a positive ROI in their business case, and they got 38 gig of packet traffic at the same time. A significant win. So the different applications we have are, a DACS and SONET core replacement, right? And that's in the upper left here, where we're going to replace not only the MSPPs, but the DACSs, because the 1400 will do the DACS functionality as well, all the rooming, all the test set requirements. SONET aggregation replacement, SONET core replacement, right? Mid-span meets, wholesale backhauls, TDM services, and even consolidating the DS1s that are picked up from a GPON network that come in from an ONT, go to an OLT. We'll take it from, in this example, it was a Calyx OLT, and migrate it, take an Ethernet port off of those OLTs into a circuit emulation server, and then hand off DS1s or OC3s to the core networks. So there's multi-vendor interoperability as well. And so far, we've been successfully looking at replacing and have replaced Cisco network elements, Lucent, Fujitsu, Nortel, Turin. We've interoperated with all of those as well, all on the 7 slot, right, or the fixed P, right? The P being smaller for like 16 DS1s and some Ethernet traffic. The service control is very effective around all of this. The NMS is capable of running all of these services on a single pane of glass, right? And there are wizards that remember your service type and guide you through the provisioning of a service or the network itself. We also have bulk provisioning methodologies that will aid in quick transition of the network structures from a SONET overwards. So in summary, the Tejas Network solution, it's standards-based, right? We use MEF8, MEF3, we're MEF carrier Ethernet compliant for the transport of the services, and for other Ethernet services you want to do. We bring in the latest technologies to lowest your cost per bit. The NMS provides extremely easy migration from a SONET-based infrastructure to a packet-based infrastructure for your TDM services. We have proven deployments throughout the US, right? And we have partners that are capable of helping you in all manners, right? Whether that be the engineering or installation pieces of it, as well as the transition MOPs themselves. So we have not only ourselves to help you out, but partners that can come in and help you in anything that you would need to have to transition your network.